Q04 is about symmetries. So what kind of symmetry does it have? So we can see that this ellipse, if we were to go along the x-axis, the top could fold over to the bottom, so it definitely has x-axis symmetry. For the same reason, it has y-axis symmetry, right? This could fold over to that, so we're going to check that one off. It also has origin symmetry, so that, let's see, does it? If you spin it 180 degrees, that's what I call, origin is kind of like, I refer to as spinner. And so if you take a point and you spin it 180 degrees, does it land, will the figure land back on itself? Yes, it will. This one goes 180 degrees, it lands over there. So you just imagine this little oblong shape going 180 degrees. It has symmetry around the origin. And so, a value over here that has a negative x value has a positive y value. If you go at 180 degrees, you get this point over here that has a positive x value but a negative y value. So negative x, positive y, and then what changes is you get a positive x with a negative y. So another way of looking at that kind of symmetry. So yes, that does, none of them doesn't make sense because it has all of them, right? So we'll click on those. Graph 2, a square root function. It does not have x-axis symmetry. Again, if you go along the x-axis, if you fold this over, no, there's no symmetry there. It doesn't have y-axis symmetry. If you flip it over, it doesn't land on itself. And for those same reasons, if you were to flip it over or spinner, you'd get something like this. That's not, and there's nothing there. So this one has no symmetries. And we'll look at this last one. It's an x cubed function. Hopefully you recognize that, x to the third. And it does not have y-axis symmetry because this, if you fold this, if you reflect it over here, there's nothing here. And same as over here, it doesn't go down. No x-axis symmetry because if you reflect over here, you don't have a part there. So none of these don't work. But it does have the, what I would call spinner symmetry, so that if you spin this over, yes, it does land there, and that would go up there. And again, what you look at is we can look at maybe a specific point. This point of 2, 1 is what we start with, and then when we spin it over, we get it changing to -2, -1. So that was part of the definition. If you put a negative on it, right, it's going to go to the opposite point as far as the negatives changing. So this one does have origin symmetry. Okay, so those are the way we kind of look at those. Thanks.